Hello everyone, welcome to a new session. In this session we'll be learning about the reflection. As we explained before, the reflection is like mirroring across the x-axis or the y-axis, and we're going to see that we will have reflection across the origin point. Reflection on any straight line. The reflection on a straight line L maps each point A to the point A dash in the same plane such that here, if the reflection across a vertical line where A does not belong to L, then the straight line L is perpendicular bisector to the line segment A dash A. 2. If B belongs to L, then B is reflected into itself where B dash coincides with B. Let's continue the reflection on a straight line. Let's go to see some properties of reflection in a line. Reflection reserves length of line segment. Reflection reserves betweenness property. Reflection reserves measures of angles. The reflection reserves parallelism. Let's go to see exercise number 1. ABCD is a quadrilateral in which the measure of angle A is 100 degrees and AD is parallel to BC if the figure XYZN is the image of the figure ABCD by reflection in the straight line L. Find the measure of angle Y. If XYZN is the image of ABCD, therefore, the measure of angle A is equal to the measure of angle X, which is 100 degrees. Since AD is parallel to BC as given, therefore, it's also XN is parallel to YZ. Therefore, the measure of angle Y is 180 minus 100, which is 80 degrees, because this is the interior supplementary. Let's now move to another part, which is the reflection in the Cartesian plane. If you have point A that has coordinates x and y, and the reflection is in the x-axis, remember this very well. If the reflection is in the x-axis, we change the sign of y, but x remains as it is. So, reflection in the x-axis, we change the sign of y. Reflection on the y-axis, excellent, we change the sign of x. So, A dash will be x, negative y, where A that has coordinates x and y with reflection in the y-axis will have A dash as negative x and y as it is. Let's see these remarks. The image of the point x0 by reflection in the x-axis is itself because it lies on the x-axis. 5, 0, if you change the sign of y, it remains 0 as it is. Same idea, the image of the point 0y by reflection in the y-axis, it's itself because it lies on the y-axis. For example, 0, negative 3 by reflection in the y-axis, so we change x, so 0 remains as it is as 0, negative 3. The image on the point 0, 0 by reflection in the x-axis or the y-axis is itself because it lies on both the two axes. Exercise number 2. Draw on a square lattice the triangle ABC where A has coordinates 9 and 5 and B has coordinates 6 and 1, where C has coordinates 2 and 2. The question wants me to draw triangle A-B-C-, which has the images of ABC by reflection in the x-axis. By reflection in the x-axis, This means that the A will have an A dash as, yes, excellent, X remains as it is, and we change the Y. So here is the A dash. About the B dash, the B is 6 and 1, so it will be 6 and negative 1. Then go and plot it. C, it has coordinates 2 and 2. We keep X as it is, we change Y, so it's 2, negative 2. We plot it and then we connect between them. Question 2, the question wants me to draw the triangle A double dash, B double dash, C double dash, which is the image of A dash, B dash, C dash, by reflecting the new one in the y-axis. So here we're going to reflect the A dash on the y-axis. So A double dash will be the changing of the sign of X, so it's negative 5, while the Y remains as it is. So to find A double dash is the reflection of the A dash on the y-axis. So reflection on the y will change the sign of X. So it will be negative 9, negative 5. Then we plot the point. B double dash, same idea. We reflect the B dash across the y-axis. So we change the sign of X. It will be negative 6, negative 1. Where C double dash is the reflection of C dash on the y-axis, so we change the sign of X, so it will be negative 2, negative 2. Let's now go and plot the points together. A double dash is negative 9, negative 5. Here is A double dash. B double dash is negative 6, negative 1. Here is the B double dash. And C double dash is negative 2, negative 2. And then you connect between the 3 points, the A double dash, the B double dash, and the C double dash. Let's now move to the axis of symmetry. If the reflection in a line transforms the figure to itself, then this line is called an axis of symmetry of the figure. The isosceles triangle has only one axis of symmetry. The equilateral triangle has 3 axes of symmetry. The scalene triangle has no axes of symmetry. The rectangle has 2 axes of symmetry. The square has 4 axes of symmetry. The rhombus has 2 axes of symmetry, where the isosceles trapezoid has only 1 axis of symmetry. Let's now go to the evaluation part. As I always remind you, dear students, when you see the questions, pause the video, answer the problems yourself, then play the video again to check your answer. Question 1. Find the image of triangle ABC where A, B, and C have these coordinates by reflection in the x-axis. We know that reflection across the x-axis, we change the sign of y while we keep x as it is. So A dash will be negative 6 and 1, where B dash will be negative 2 and 1, and C dash will be negative 5 and 6. Question 2. Draw the image of a triangle ABC where A has coordinates 0, 0, B has 3, 0, and C has coordinates negative 1 and 2 by reflection in the y-axis. We know that reflection on the y-axis, we change the sign of X. So A dash remains as it is 0, 0 because there is no negative 0. The B dash will be negative 3 and 0, where the C dash will be 1 and 2. At this point, dear students, we came to the end of our session. Thank you very much. Wishing you best of luck.